students, good morning to each one of you. Hope so you all are fine and enjoying these digital classes. Dear students, welcome to digital classes under theme समय 10 से 12 वाला हर घर बने पाठशाला. This is your chemistry period and we are doing unit 2. Name of the unit is solution, and today we will discuss about the ideal and non-ideal solution. So before going to start, dear student, as usual, let's start with the positive mindset. Today's thought: great things never come from comfort zone. Yes, dear students, if you want to achieve great things in your life, then dear students, you have to go beyond your comfort zone. You won't get anywhere by doing what you are used to do. You need to go beyond what you think you can do in order to see in your under your potential. Okay, so all the development comes from outside your comfort zone. You need to come out from that zone where you are sitting comfortably. Okay, please don't take this nowadays in different way. I'm not talking about to go out from your home during this lockdown period. In general, I'm telling, if you will come from your comfort zone, then you will become more confident and sociable person when you get out of your comfort zone. Dear students, why people do not want to leave comfort zone? Because they're scared. They're scared to step into the unknown. They're scared of failure. But if you listen to those fear, you may never realize that what you will get after the success, what beyond that, after achieving that what you want to achieve, you will become a unique personality. You will become a different personality. So to bring success to us in our life, we need to leave our comfort zone. Okay, so this is the kind message to all those students who are sitting at home, just clicking whatever we are sending, not going through the videos properly, not going through the assignment properly, and just showing that they are studying, but I know they just going through those topics and not doing real hard work. Okay, so dear student, once again it's my appeal. Nowadays all the educational institutions are closed due to this lockdown, due to this pandemic corona. The day by day the situation is becoming more critical. I don't think so very soon the normal school routine will be come. So this year you have to be study like this way as until the situation will not become normal. So once again, it's you people that can make difference. So please do work, keep self-confidence, keep self-motivating yourself, and wherever you are facing problem, we are all the time here to help you. So please leave your comfort zone and try to do for your betterment. Okay, so just recapitulate the solution chapter. In this chapter particularly, we discuss about the solution and its types. We did chemistry in solution, which is also known as ways to express the concentration of solution, where we discussed mole fraction, mass percentage, molality, all those things, and numerical related to those topics. Hope so you understood. Then we studied about solubility and its types, as in the yesterday's videos I have shared. Solubility of solid in liquid, solubility of gas in liquids. In solubility gas in liquid, we discussed about the Henry's law, where the factor pressure is related to solubility. Then vapor pressure of liquid solution we did. Two liquid solution is showing two volatile and non-volatile solutions. Under that, non-volatile, Raoult's law for non-volatile solutes we are discussed. So today we are going to study about the ideal and non-ideal solution, which is also one of the very, very important topic in this unit. So especially before going to start about difference between ideal and non-ideal, let's discuss about the Wiener solutions. So basically, ideal and non-ideal solutions are occurring in the Wiener liquid solutions. It may be classified into two ways. One is ideal solution, second is non-ideal solution. So let's discuss the ideal solution. An ideal solution may be defined as the solution which obey Raoult's law exactly over the entire range of concentration. Once again, which obey Raoult's law. Now dear students, you should know Raoult's law, otherwise you will face problem in futures in the upcoming topics. So let's clear the Raoult's law. What is the Raoult's law? Raoult's law was at a given temperature, the vapor pressure of a solution containing non-volatile solute is directly proportional to the mole fraction of the solvent, in which vapor pressure of solution which is containing volatile solute or non-volatile solute is directly proportional to the mole fraction of the both the components. Okay, so this is Raoult's law. If any solution which is obeying this Raoult's law, which is following this relationship, then it is called an ideal solution. If the solution which doesn't obey Raoult's law and over the entire range of concentration is called non-ideal solution. Similarly, such solutions are formed by mixing the two components which are identical in molecular size. If it is identical in molecular size, identical in molecular structure, identical in intermolecular interaction, that kind of solution is ideal solution. If it is not identical, it is different in size, different in structure, different in molecular interaction, then it is a non-ideal solution. Okay, so if we will difference, this question is coming, this is the most important question, if I'll say, from this chapter. Last year also it was asked in the board examination. So dear students, you need to learn this question, you need to write this question, and you need to go through this question. Differences between ideal solution and non-ideal solution. In very simple way, 5 differences I'm going to tell. First difference is on the basis of Raoult's law. So ideal solution is obeying Raoult's law under all the temperature and concentration. Non-ideal solution do not obey Raoult's law at all temperature and concentration. As in, for example, P1 is equal to P1 not X1 and P2 is equal to P2 not X2. It is the ideal gas solution in which P1 is not equal to P1 not X1 and P2 is not equal to P2 not X2. Then it is non-ideal solution. Second difference is we will take on the basis of deviation. There is no deviation, no positive negative deviation in ideal solution, but there is positive and negative deviation in non-ideal solution, which we will study in the further topic. Third, the interaction between components, the interaction between intermolecular components are similar to those in the pure components, whereas in non-ideal there is no interaction. It is different, not similar, it is different than the pure component. Fourth is on the basis of enthalpy change. There is no enthalpy change in ideal solution. Delta H is always equal to 0, whereas in non-ideal solution there is enthalpy change, though delta H is not equal to 0. Fifth difference is on the basis of volume. No volume change on mixing. Delta V is equal to 0, whereas in non-ideal solution volume will change on mixing. Delta V is not equal to 0. So after differences, there are some examples of ideal and non-ideal solution. As ideal solution, here there is no positive negative deviation, so there are simple examples. Benzene and toluene, same size, same structure, same intermolecular interaction. So these are ideal solution. N-hexane, N-heptane, bromoethane, iodoethane, chlorobenzene, bromobenzene. These are some examples. You need to learn these. And non-ideal solution are positive and negative deviation. So different examples are there. For positive deviation, there are ethyl alcohol and cyclohexane, acetone and carbon disulfide, benzene and acetone, carbon tetrachloride, dichloroform, acetone and ethyl alcohol and water. These are positive deviation. These are showing positive deviation. What is the meaning of positive deviation and negative deviation? That we will do in the next slide. Negative deviations. Examples are acetone and chloroform, chloroform and diethyl ether, chloroform and nitric acid, acetone and aniline, water and nitric acid, and diethyl ether and chloroform. So especially these examples can ask in examination. So please go through this example, learn this, cram this. Okay. Next is types of non-ideal solution. So what is non-ideal solution before going to proceed for types? So non-ideal solution, once again, the solution which do not obey Raoult's law over the entire range of concentration are called non-ideal solution, in which PA is not equal to PA naught or XA, or P1 is not equal to P1 naught or X1. Okay. So non-ideal solutions are basically, number one, none of the component obey Raoult's law. Delta H is not equal to 0, delta B is not equal to 0. The non-ideal solution do not obey Raoult's law and accompanied by change in enthalpy and change in volume during their formation. So there are basically two types of non-ideal solutions. One is positive deviation from Raoult's law, second is negative deviation from Raoult's law. Let's understand positive and negative. Positive deviations, in which intermolecular interactions mean the interaction of solute and solvent. As you know, in that solution which is made up, binary solution which is made up of one solute and solvent, that solute and solvent are weaker. They are weaker than the pure component, means solvent, solvent, solute, solute. The interaction of solute, solute and solvent, solvent is more in this particular case than the solute, solution, solvent. So in the other negative deviation, there is intermolecular interaction of AB are stronger than the pure component. Okay, so that's why it is showing negative deviation. These are the two graphs. Positive deviation is showing as dotted line. It is the normal gas in the Raoult's law we studied, mole fraction and vapor pressure. It is the normal line. But if the deviation is above the normal line, you can see from PA naught to PA. Let me tell you with the help of this pen. Okay, so sorry. Okay, so this is the normal line. These are normal line, and the deviation which is above, if this is PA is above, and this side it is PB. PA is solute, PA is vapor pressure of solvent. So this line is above PA and PB. So this is becoming P is equal to PA plus PB, which is showing the positive deviation as it is written here also. You can see positive deviation from ideal behavior. The dotted line represent ideal behavior and the solid line represent actual behavior. In actual, it is showing above the normal behavior, that's why it is called positive. And on the other hand side, it is showing below the normal line, that's why it is called this is, you can see below the normal, that's why it is called negative deviation. And negative deviation is same, the dotted line is showing the ideal behavior and the solid line is showing actual behavior. It means that the behavior of solution is not equal to the actual behavior. It is not like actual behavior, that's why it is called non-ideal solution. So try to understand both the graph from the PDF also, which I am going to share. So next, what is the difference between positive deviation and negative deviation? So intermolecular interaction, again intermolecular interaction, if intermolecular interaction is weaker in AB than the AA and BB, then it is called positive deviation. As P1 is greater than, the pressure of solution is greater than the pressure of solvent and solute. In this case particularly, delta H is positive and this solution is endothermic. If delta H is positive, so it is endothermic, mean energy is going to be from outside to inside, or energy is going to be absorbed by solution. So heating increases solubility here. In this case particularly, heating increases with the temperature and delta volume is also positive. On the other hand side, negative deviation, intermolecular interaction is AB is stronger than AA and BB. That is because P1 is less than P1 naught and X1 and P2 is less than P2 naught X2. Here you need to understand about the P1 and P2. P1 is solution. Okay, solution vapor pressure of pressure of solute with the vapor pressure of solute in component 1, and P2 is the vapor pressure of solvent in component 2. Okay, in this particular case delta H is minus or negative because it is exothermic, it is releasing heat, and if heat is releasing, so heating is decreasing with the solubility, means solubility is decreasing with the low in temperature, and delta volume is always negative. Okay, so this is also one of the important differences you need to study. Dear student, we will study 3 basic differences in this particular video. First is a difference between ideal and non-ideal that we did. This is second, positive deviation, negative deviation, especially the types of non-ideal solution. Third will be azeotropes. This is there. What is azeotrope? Now up to this non-ideal. Now azeotropes are some special type of binary solutions. Now I need to understand now. Special type of binary solution mean that the solute and solvent, which is mixing solute and solvent, their evaporation rate, their boiling point will not change if we will take it in the liquid and gas case. Okay, in the case of liquid. So Greek word, azeo word mean Greek. It means boiling without changes. Boiling without changes. Okay. So in Greek it means boiling without changes, and it is also known as constant boiling mixture. Okay, so definition is the solution, it is the liquid mixtures, the solution which is liquid mixture which boils at constant temperature, but not changed its composition. Again, azeotropes, definition of azeotrope, these are liquids mixture which boils at constant temperature. They have constant temperature, and when they boil they will not change its composition will not change, its composition remain unchanged. Okay, so there are 2 types of mixture, azeotropes mixture. One is minimum boiling, second is maximum boiling. Here I want to tell you positive and negative deviation we have studied. Positive deviation which has weaker than pure component, negative deviation which has greater than the pure components. Here minimum is showing positive deviation. It means that all the properties of characteristics of positive deviation is minimum boiling azeotropes. All the properties of negative deviation is the maximum boiling azeotropes. Okay, so solution showing positive deviation form ideal behavior, it is called minimum boiling azeotropes, and maximum boiling azeotrope solution which showing negative deviation from ideal behavior for maximum boiling azeotrope. In detail you can study from the PDF notes. So this is all about this ideal and non-ideal solution, but today I have brought in this special video some of the key points, formula units and special notes which will can ask in the examination, and which can also be studied with the help of these formula, special part. So formula and units. Solving numerical problems. There are some formulas as we have studied. Molarity. Molarity's formula is, it is showing with the capital M. Formula is mole of solute upon volume of solution. Dear students, just recap revise all the things whatever we have done with the help of these slides. So molarity is capital M, mole upon solute upon volume of solution, multiply by 1000. Molality is small m, moles of solute upon mass of solvent. So difference is only in volume and mass. Here it is volume, here it is mass. Okay, and normality is what? Capital N, in which gram equivalent solvent. Now solute we will take in gram equivalent. You know what is gram equivalent? We are taking it is in the form of gram upon volume. It is like a molality, normality, but difference is only here mole we will take, here gram we will take. If we are taking in case of mole, okay, mole is what? How to calculate mole? It is given mass upon molar mass. Okay, and this normality, in case of normality, there is no gram upon mole, it is simply gram. And normality, how to calculate? It is simply molarity into mole upon equation mass. Clear? So mole fraction is mole of solute upon mole of solute plus mole of solvent if we are finding mole of solute. So this is also, and it is written here XA is equal to 1 minus XB. This is, you know, in previous topics we did. Key points of the units mean graphical representation. So see, in the graphical representation, Henry's law, it is showing graphs between mole fraction and partial pressure, and Rod's law showing mole fraction with vapor pressure. Here it is partial pressure, here it is vapor pressure. This is the difference. And some of the curious point we will take: the difference and similarity between Rod's law and Henry's law. Yesterday we discussed. In similarity, Rod's law and Henry's law both apply to volatile component. Both laws state the vapor pressure of one component to proportional to mole fraction. In differences, it is defined proportionality constant as vapor pressure, and Henry's law proportional constant of same experimentally determined value. Okay, and maybe some of the in some of the cases this question can ask in PMT also. Sometime it is asking aquatic species like fish feel more comfortable in lake in winter than in the summer. This already we have done. Just think what is the reason. The reason is aquatic species require dissolved oxygen for breathing. As solubility of gas decreases with the increase in temperature. The main reason is this: as solution is increasing, the solubility of solution increasing with the decrease in temperature. That's why the aquatic species are feel comfortable in winter than the. Okay, some of the keynotes are like mole fraction. The term mass fraction is also used. It is the mass of a given component per unit mass of the solution. So it means that there we are using XA is equal to NA upon NA plus NB. Here we will use XA is equal to WA upon WA plus WB. Similarly, XB is equal to WB upon WA plus WB, and XA plus XB is equal to 1 always. Mass fraction multiplied by 100, and because percentage is always in 100. Like mass fraction, volume fraction may be also defined. That time we write in place of WA VA then. Okay, relationship between normality and molarity already we have done. So once again you can go through. There are positive negative deviation chart or graph, you can see this also I have discussed you with the help of this. And there are some interesting fact also: which type of mixture form azeotrope. Maybe this question came, which type of mixture form azeotrope. So pure ethyl alcohol cannot obtain from rectified spirit, 95.6% of alcohol in which, even by fractional distillation. Reason: because it is azeotropes. This is because the mixture of 95.6% alcohol and 4.4% water form azeotrope, and azeotrope cannot be azeotrope or binary mixture which can, after attaining the constant boiling point, it cannot change its composition. That's why it is a constant boiling mixture. At this stage, liquid and vapor has the same composition, and therefore it cannot separate it with the help of fractional distillation. So one fact is there: azeotrope cannot separate with the help of fractional distillation. Dear students, keep this note down. Relation between deviation and azeotropes. Similarly, as we have said, positive deviation is showing minimum boiling azeotrope, negative deviation is showing maximum boiling azeotrope. Okay, so this is all about for today. Hope so you enjoy this video, and you need to subscribe. करो कुछ ऐसा दुनिया याद रखे YouTube channel just for to watch all the videos related to these digital classes. So thanks for watching this video. Once again, I'm going to appeal you just to break this chain of coronavirus. Stay home, stay safe, don't go out of your home, and just think about your families and yourself. Okay, so thank you, have a nice day. Thank you.